HA is, what about admission control? So how am I going to define my admission control? And this is typically something that shocks a lot of customers, and it surprised me as soon as you start talking about, well, I need to set aside half of your resources for admission control to guarantee that virtual machines are restarted. First thing customers will say, well, that's going to be really expensive. Yeah, I know, but the cost of the storage system was also quite significant, and you bought it for a reason, right? You had a requirement to have really fast RTO, so that's the reason you have this. It also means you need to set aside a set amount of hosts. Now, the one thing someone mentioned during the discussion group you had this week, which I found is a nice solution for admission control, is what they did is they designated an X amount of hosts. So you can specify an X amount of hosts to be a failover target. So what they did is they had a site A, where all of the virtual machines were running, and all of the hosts in site B, they designated those as a failover target. So they're not used by HA or by DRS in a normal way, or in a normal situation, only when there's a failover event. Now, this has some advantages and disadvantages, of course, because the hosts are sitting there doing nothing. They're not servicing any workloads at that point in time. But then again, it is a guarantee that if site A fails, all of the virtual machines will be restarted in site B. Now, the other way of doing this, of course, would be by specifying, for instance, a 50% for both compute and for both CPU and memory. That's also a way of guaranteeing virtual machines will be restarted. Now, the one thing to realize when we talk about admission control is that admission control is all about restarting a virtual machine. And from a host perspective, the only thing that a host needs to restart a virtual machine is basically memory overhead and the reservation you specify. So if you think about that for 2 seconds and you look at your application itself and you look at the amount of resources that it's consuming, so let's think about a virtual machine which is 8 gig of memory and is actively using 7 gigs of memory. Now the memory overhead of that virtual machine might be 250 megabytes. If you haven't specified a reservation, then HA will do admission control calculations with that 250 megabytes instead of that 7 gig that you're actively using, or at least that your customer is actively using. So admission control is not only about vSphere HA admission control. When we start talking about admission control and guaranteeing your customers the same level of experience before the failure as after the failure, is also about things like VCOps, monitoring your environment from a DRS perspective, making sure that you're not consuming more than 50% of those resources, because otherwise after the failover you will notice that those virtual machines will not be getting the exact same amount of resources as before the failover. And before you know it, someone will be standing next to your desk and asking, hey, what's up? You paid a lot of money for these virtual machines to make them highly available, and guess what? Now something happened, and I get a different service level than I expected to be getting. So that's something to keep in mind. Now, from an HA perspective, this is stuff that we're working on. This is stuff that we're looking to improve. So in the future, what we're trying to do is start using for admission control, for instance, the average amount of resources used for a single virtual machine or for a group of virtual machines, and take that into account as well, and provide you with the right set of information to make decisions to scale out your cluster or scale up your cluster, whatever is needed. So there are things coming up in the future that will try to at least enhance this experience or improve this experience. Now the other thing when we talk about vSphere HA that you need to think about is the isolation response. So the isolation response is the way vSphere HA responds when a virtual or a host is isolated from the network. Basically this means if a host currently is isolated from the network, the default setting is that the virtual machines will be sitting there on the host doing nothing. So they won't be powered off, they will just be sitting there. Now you can imagine you just invested in a large environment, many hosts, stretched storage environment, you went through all the networking stuff, and a failure happens to your switch, and half of your virtual machines are just sitting there doing nothing. So in that case, you would like HA to respond. If you like the HA to respond, you need to set some changes on the cluster level. So you have 3 options here. You can either power up the virtual machine, which is kind of like yanking out the power cable from a host. So we kill the VMX process and that's it. The other option is you can shut down the virtual machine, for which we use the VMware Tools plugin, which means you need to have VMware Tools installed. If you don't have VMware Tools installed, we'll still yank that cable. And the other option is leave the virtual machines powered on. Now, typically you would make this decision based on the type of hardware you would have running and the likelihood that a virtual machine is unavailable from a network perspective at the same time as the host is unavailable from a networking perspective. So you can imagine, for instance, in a converged network environment where you have storage and VM traffic, vMotion traffic, and management traffic all running across the same NIC, that it's very likely that when a virtual machine is not accessible, that the management traffic is also not working and storage is also not working. So at that point in time, you probably will want to power off the virtual machine or shut down the virtual machine. Now, considering you won't have any storage connection, there's no point in shutting it down because it won't be able to write or flush any data anyway. So killing it is probably the best option. Another thing that has got to do with the isolation response that we just discussed is the isolation address. So the isolation address is an address that vSphere HA will check itself as soon as it notices or it has the feeling it is isolated. So what happens? You have a single host running attached to a single switch or to multiple switches. As soon as, for whatever reason, that host doesn't receive any heartbeats from the master, what it will do is it will ping the isolation address to validate if it has isolated or if the master potentially is isolated, because that's also an option, right? The master can either, it can die or, you know, it can be isolated itself. In that case, we will ping the isolation address. Now, by default, we'll use the default gateway that you specified during the ESXi installation. But because you're using a stressed cluster environment, potentially that default gateway could physically be located in one of your sites. So just imagine there's a split between those two sites and something happens to one of the nodes, and you only have the default gateway for HA to check if hosts are isolated or not. Well then, an isolation event might be triggered and virtual machines might be powered off for no reason. So you can specify multiple isolation addresses, so as soon as you start deploying these configurations, make sure you specify multiple isolation addresses and make sure that each one of these, as soon as you specify multiple, that these are actually located in both of these sites. As I already briefly mentioned during the introduction of vSphere HA, we introduced something new which is called heartbeat data stores. And heartbeat data stores are the second level of validation for us to see what happened to a specific host. So either has it isolated or is it completely dead? What do we need to do with these virtual machines that are sitting there doing nothing at this point in time? Now, if you install and configure vSphere HA, by default, what vSphere will do for you, what vCenter will do for you, it will select two completely random fiber channel, preferably data stores as the heartbeat data stores. Now you can imagine, in a stretched cluster environment, as Lee has already explained earlier, these data stores will have affinity with either site A or site B. Now, if vCenter, for whatever reason, has selected all those heartbeat data stores that reside in site A, then when something happens in site B and the connection is down, which is not likely, but it can always occur, then the hosts in site B won't be able to do anything with those heartbeat data stores because it simply can't connect to those heartbeat data stores. So we provide you an option for that. And you can specify which virtual machine should be the heartbeat data store. Plus, you can increase the number of heartbeat data stores as well. So first of all, the default number of heartbeat data stores that you will get is 2. Now we recommend to increase this to 4 so that you will always have resiliency within the site, so 2 per site, and you have multiple spread across the sites. Another consideration that typically passes by, and this is kind of a myth that is floating around within the industry, is that you can use the restart order priority to determine in which order virtual machines are powered on. And you can actually do that to a certain extent. And to a certain extent, I mean, when we're powering on virtual machines, so when HA starts powering on virtual machines, it takes this ordering into account when it creates the list of virtual machines that needs to be restarted. So if you have, let's say, 100 virtual machines sitting in one site and a host fails, then the HA master will determine the list of virtual machines that need to be restarted. So let's say that's those 100 virtual machines. And HA will just start restarting virtual machines. It will do that based on this order, and it will do that 32 virtual machines at a time. So it can schedule 32 virtual machines per host in your cluster. So you can imagine if you have a large cluster, the amount of virtual machines that can be powered on at the exact same time is quite significant. Now you've set all these nice restart priority options, so you figured, hey, you know what, I have this database server up running, and I have my web app, and I have a middle tier, and I've set these orders so the database is going to come up before the rest of the virtual machines. Shouldn't be a problem because I gave it high priority. But as I just mentioned, we're talking about restarting virtual machines. We're not talking about the full boot up of a virtual machine itself. We're not waiting for the VMware tools to heartbeat. We're not doing any of that. We're just restarting the virtual machine, which means we create this virtual machine process of one of the hosts. So at that point, the next virtual machine or the next priority virtual machine will be restarted. So if you have 20 hosts in a cluster and you can restart 32 virtual machines per node, even if 100 virtual machines fail at the same time, those will all be restarted in a matter of seconds. And typically what happens is that large virtual machine that is running a database will probably take 10 to 15 minutes longer to power on because it's going through all recovery steps and whatever. So your web server will be up and running, your middle tier will be up and running before your database is up and running. So although this is useful to a certain extent, be aware of those caveats. So document the failover order of your virtual machines as well. Now, of course, this is something we're looking to extend in the future, and hopefully we'll be able to release something probably in the next release. We're still discussing that, but we're going through the design options today. I wrote an article about this exact topic, about HA futures, and it's explaining some of the things that we are exploring. So one of the things that we are exploring is actually provides you with this dependency chains within HA, not unlike Site Recovery Manager offers you. So you can group virtual machines and then specify the dependency between those virtual machines. So HA will take that into account when it restarts a virtual machine. And it can potentially, for instance, also wait on the VMware tool. So that will allow you, at least from an application perspective, to guarantee that virtual machines are restarted in the exact same order every single time, and specific virtual machines won't be restarted before other virtual machine restarts are completed.
Okay, so for this last section, we want to take you through some of the failure scenarios. So just so that you get an understanding of what things are going to fail and how they could fail and how you can kind of alleviate that. So first thing to say is test this before it goes live. I mentioned this earlier, I can't stress this importance enough. Make sure you test failure impacts. Make sure you use the KB articles to validate that you've got your zoning correctly, the settings are incorrectly. Don't be one of those customers that brings me up and says, this storage solution doesn't work. Well, actually, we found it was just a single setting inside the UI that I forgot to do that made it work. And we all remember the early versions of HA, version 3 and 4, where the isolation response caught a lot of customers out when they had a slight network blip and only VMs powered off, and you ran support and why have all my VMs powered off? And it was just because the isolation response was set that way, which lots of nodding heads. Like, yeah, we remember that. Thanks a lot, VMware. Hopefully, as Duncan said, HA is a lot more resilient than that today. But the same thing is going to happen on a larger scale in a stretched environment, so make sure you test these. Also make sure when you're testing things like partitions and frame failures, make sure you keep the test realistic and work with the storage vendor. There's a fine line between testing and sabotage. I know customers have a tendency to want to come in and say, look, it's almost like the old Roadrunner cartoons. Like if I go in with a dynamite stick and throw it in the back of the VPlex cabinet, it didn't tolerate that one. And it's a different kind of test to what maybe the storage vendor is envisaging. So you've got to keep it realistic. I mean, there's some test scenarios I've seen people do which are not really realistic. It just starts to get a bit difficult. So yeah, make sure the tests are realistic for you. Know what you're trying to test is I guess what I'm trying to say. And do that before you go into production. Don't wait until you're in production to start doing these testings. From our side, there's two things that cause a lot of confusion, so it's worth spending a bit of time on that, and that's essentially these first two elements here. This is essentially all paths down and permanent device loss. So as a baseline, if you're going to deploy one of these solutions, you must use 5.0 update 1 or 5.1 as a minimum. If you don't use those versions, so if you're sitting on 5.0 GA code, you won't have any of the permanent device loss code working properly inside of your settings. You'll have seen, if you've looked at the release notes for 5.1 and 5.5, that we've added various things and features in for things like all paths down. All paths down is what it sounds like. It's when I've got no paths available to any of my devices. All paths down can still occur despite those new settings. Some people think that the APD timeout value that we added in 5.1 can magically do things to SCSI sense codes and make things seem nice and rosy. It can't. There's no magical conversion of sense codes. If you're in an all paths down situation, you're in an all paths down situation. If you look at the host D logs on ASX, you'll see the error message, so you'll know that you're in that scenario. We introduced PDL for the failure scenarios where we can receive information back from the storage layer. So if the storage controllers are available, the storage virtualization layer, say from a vPlex or an SVC environment is available, if devices go offline, we can get SCSI sense code back from those controllers that says, hey ESX, this device is gone, don't expect it to come back anytime soon. Why does ESX like that? I'm sure all of you know from earlier versions of ESX. ESX has got a bit of a checkered history in how it handles situations where devices go offline. The usual result for the customer was host D went into a flat spin, CPU spiked up, host D threw all its toys out of its pram, and you saw your host disconnecting from Virtual Center and then rang us in an angry tone of voice because all your VMs are locked up, and quite rightly so. And that doesn't occur now in the later versions of ESX, but we can still get into those states. ESX can just handle it better now, so host D stays nice and calm. Its heart rate doesn't zoom off the chart. It just understands what's happening. So make sure you're on those ESX versions. In PDL scenarios, we have got settings we'll look at in a second, handle those failures from an HA point of view. But you must still understand that APD is possible. APD is still possible in certain failure events. So it's not gone away, it still is there.
So one thing to note here around APD, and he has already mentioned, we don't actually do anything about that today. We are working on solutions that will solve these problems in the future. Right? From an HA perspective, we are working on something called VM component protection. There was actually a session about that last year, so if you have the VM subscription, you can actually see that session last year. It might even be up on YouTube. So it's called VM component protection. And what we're trying to do is work around some of these APD scenarios where we will actually allow you to power on virtual machines on hosts which are not in an APD scenario. So it's something that's being worked on.
And to get into one of these scenarios is actually quite difficult and very unlikely with the storage solutions that we've been talking about today. To get into an APD on most of these solutions today, you would not only have to have both storage controllers fail at the same time on the same site, but also both of your fabrics would have to fail at the same time on the same site. And usually if all of those double failures had occurred, you've probably actually had a site failure, which means everything's going to fail over to the other side anyway. So it is very easy to get very fixated on some of these failure scenarios, but they are quite rare. There are, like I say, ways coming where we can help you get out of those today, and obviously we're going to build that into vSphere in a future release. But you've also got to put this into context of what it is I'm engineering to build here, because dual site failure, UPS failure, dual fabric failure is hopefully something that doesn't happen all the time. APD is still possible. So one of the things that you can do to enable PDL, so you must do this if you're working in a stretched storage environment, is we have some settings that you can turn on at the ESX layer and the cluster layer. The settings states have changed, which is something that we also have a history of doing inside VMware occasionally. We have a setting that's false in one release and true in the next, and then back to false in the one after. So hopefully this will stay consistent now. But as you can see, the mass clean shutdown enable setting that we insist you use in stretch clustering was false in 50U1, so you must change it if you're on that code level. And it's true in 5.1 and up, so leave it alone. It needs to be set to true in those particular versions. And what this will actually allow HA to do is to react to the events when a PDL has occurred. When a PDL occurs and a device goes away, as you'll see on the next slide, we have a setting that allows ESX to essentially kill the virtual machine process through the SCSI layer, and then HA can respond to that and restart the virtual machine in those scenarios. So at the host level, the element that does that is this, it's quite a mouthful to try and pronounce this when you're on stage. It's disk.terminate VM on PDL default. So 5.1, 5.0, make sure you set that to true. In 5.5, we've got a screenshot there from the 5.5 environment. We have that as a UI feature, so you don't have to go and set that manually on the host itself. But enabling that will essentially allow ESX to kill that VMM process if it detects a PDL sense code coming back from the storage controller. So it's not actually HA that kills the VM, it's actually ESX itself that kills the VM when it gets that sense code back. So if you don't do that, then essentially what happens is the VM will just hang and sit there on the host itself. So some failure scenarios, but we'll go through these together, don't we? So the first one we wanted to talk about is essentially a full compute failure at site A. So this is our little environment, remember again, this is a uniform environment. So here I lose both of the nodes at site A, so they're both gone, bye-bye. Normal HA events. So if that happens in a stretched environment, that's just a normal HA event. VMs will come up to the side. Nothing magical from the stretch cluster in that point of view, but obviously if you're talking about thousands of VMs and not the 2 VMs in this example, then the restart sequencing will be adhered to from HA, as Duncan explained earlier, that that's only going to take you so far. But at that point, we'll obviously be violating the affinity rules. remember when we talked about DRS affinity, if I'd have left those rules set to must, those VMs wouldn't have restarted on that side. That's why I said you should use the should rules, so that happens, so that they fail over to the other side.
Yeah, so one thing to realize here, as soon as these nodes that have just failed will return to the cluster, then DRS at some point will migrate those virtual machines back. So by default, DRS will run every 5 minutes. So you can either trigger DRS yourself by running DRS manually within the DRS cluster configuration itself, or you can wait for a couple of minutes for DRS to run itself and go over these, go over the algorithm itself and look at the rules that have been set up and migrate virtual machines between left and right.
So the next one we've got is essentially a storage partition. So Duncan spent a lot of time making those red dots do that. He's not the best PowerPoint wizard in the world, but I think he spent like 3 days getting those to work.
4 actually.
4 days. So you can write 1,000
if you like that.
So essentially here we've now got a partition at the storage layer. So management network is available from a HA point of view, but the virtual machines, the partition has happened there. Now this is an example of a uniform architecture. So this might be, say, a NetApp Metro cluster as an example here. So our 2 virtual machines, both using the same read-write device. We have a partition at the storage layer, so essentially the storage can no longer push data to the target copy. But the virtual machines don't care. Why don't they care? Because they have an ISL between the 2 sites. So each host has paths to all controllers. The storage is obviously going to be concerned at this point, probably logging errors to say I'm not pushing data to the other side. The VMs will be happy because they can still hit their target disks. So in that instance, from a uniform architecture, that's one of the advantages from that point of view. One thing to say about some of the non-uniform architectures, you may see options in the configuration to say a cross connect can be used. So if you have something like EMC vPlex as an example, where it's the non-uniform type, if you're sub 2 milliseconds, EMC will allow you to cable in a cross connect to essentially give vPlex this capability as well to make it look like uniform in that kind of failure scenario. So if you see people with that cross connect and you say, why have they done that? They've done it because they want to give the hosts access to those environments. One thing that changed, and I don't think we fully got to the bottom of why it changed in 5.1, is if you had a host configured like this, essentially you've now potentially got 8 paths to the disks. Now you can imagine in certain failure scenarios you could get an APD response down 4 of the paths and a permanent device loss down the other 4 paths. So who wins in that situation if there's 2 sets of sense codes coming back to the host? So in 5.1 and up, PDL will always win. So if the host detects PDL coming down the paths, PDL will win, which is what you want to happen. If you're on 5.0, then APD would win, which is not nice. So again, can't reinforce enough. If you're on 5.0 or you're sitting in that wondering and delaying your migration, try and get on 5.1 as soon as you possibly can. So in a non-uniform example, so again we've got the same virtual machines here, 2 independent, it's not the same VM, it's 2 separate VMs, but they're sitting on the same distributed VMFS volume. So we now have a partition, if I can up here. So what happens in this situation? So because they were sitting on the same device, the storage is going to make a decision at this point, because it can't have in a partition situation that VMFS volume read-write on both halves of the partition. So there'll always be a winner and a loser. So the storage will get yanked by the storage layer at the losing site. So our VM that just happened to be on site D, unfortunately, because the customer hadn't followed our guidelines and hadn't seen this presentation, hadn't done any affinity placement, so their virtual machine will have to suffer a restart because the storage layer will declare PDL, ESX will react to that PDL, and VM will be HA restarted on the other side. If they listened to us and put the affinity rules in place, that VM could have avoided that issue because it would have been on the right side to start with. But if that wasn't a major concern for them, they might have deployed it.
Yeah, and I guess it's worth noting here as well that the advanced settings that we just discussed, if you wouldn't have configured those, then the virtual machine would have just been sitting there and wouldn't have been killed and wouldn't have been restarted by HA either. So that's something to take into consideration when you build these environments. These advanced settings are important to configure.
And systems like this will typically have a setting at the storage layer that determines which side wins. But just like in the uniform environment, I typically see people do this 50-50 Las Vegas, some on red and some on black. So if I've got 10 distributed write anywhere, access anywhere VMFS volumes, I'll set 5 of them to be A side wins and 5 of them to be B side wins, so I'm hedging my bets on failure. There's always an option in the UI that says no winner. If you set that, that's when you ring me and say nothing failed over and the storage disappeared from both sides. So don't make that mistake. We have had people do that. I'm not too sure how they do that because that's not the default. And it was a partner that implemented that that, so they must have deliberately gone in and set it to no winner for whatever reason. It was possibly a test during the POC and they forgot to set it back again, but as you can imagine, the customer wasn't best pleased when it happened in production and they had a WAN partition down the middle, and the storage just went goodbye and just pulled the storage from both sides. 1,000 VMs disappeared in the blink of an eye in terms of power off. So, data center partition, what happens if the whole site's partitioned? So not just the storage now, but now the network as well. VM running at site A, we're now going to have the partition. Essentially, what's going to happen here is the VM is going to flip. Actually, I think I flipped too fast there. Okay, so if the VM is on the right side, then nothing will happen because it'll just stay where it is. It's IO is being served locally, it will stay where it is because the affinity design is in place for host groups, VM groups, and VM groups. If we haven't done that, then the affinity rule is violated when we have a full partition, and essentially the VM could be in the wrong place at the wrong time. And in certain scenarios, that VM in site B, for example, there is now trying to access the device on the left-hand side, and it's going to be in an all paths down situation at that time. So again, all paths down is still possible in certain deployments with certain misconfigurations.
Yeah, so what is worth noting here, the two virtual machines that you see in this slide are actually the exact same virtual machines. So this also means from a user perspective, you can access that exact same virtual machine in both sides. So if that's a database server or an application server, you still can access that database locally if you haven't set those affinity rules. So which also means that a set of users potentially can do changes to an application which will never ever be submitted. And on the other side, you have people making different changes. So you're going to be in a weird situation. So make sure you configure these rules. In this case, this is probably the most important case when we're talking about these rules.
Yeah. So this just reinforces why, again, I know some of our storage partners will say, storage solution we've got is magic, you don't need to worry about affinity, but there are certain failure scenarios where it does start to make a difference if you just align the VMs to the storage failure setting. So non-uniform, what would happen? Loss of full data center. So we now unfortunately lose the half of my site, so I lose my 2 Sunfires over there. I'm devastated because I've lost my Sunfires. But again, in that situation, nothing different. The VMs will restart on the other side. If there's been a full outage there, this is the scenarios where it's important to use the tiebreaker or witness solutions deployed by the storage vendors. So most storage vendors will have a witness option which can go in a third failure domain. This is when this becomes important because if there's a full site failure, the cluster on the right hand side from a storage point of view cannot determine what's happened to its friend. He doesn't know if he's just partitioned or has he actually failed. So it's not always required from a support point of view to have that kind of hanging judge, that arbitration engine, but it's pretty much recommended from most storage vendors. So third failure domain, which can usually just be another site or office that you've got. Most of these things are just virtual appliances that will just create a 3-way VPN connection between components in the cluster. Some of them require FC connectivity, so investigate that with the storage vendor. But the reason they become useful is because in this scenario, the witness can tell and talk to the other surviving storage nodes and say, you know what, I can't see him either. Let's assume he's dead. Bring those storage devices on at this side as well. Read write. So not only the devices that are set to win on that side, but obviously the devices that would ordinarily have been removed will now be put back again into an IO resume state. So if you don't have the witness in place, it's not the end of the world from a storage point of view. It just means in that failing scenario, you might have to intervene and say resume IO, or most vendors will have a VC plugin that will do that. So this is where the actual witness appliances come into their role when you have that kind of full site failure and one side can't figure out what's happened to the other side. So just to wrap up, design a cluster that meets your needs. Don't forget the operational importance of this. These things are not next finished solutions. You still have to maintain them over time for them to be effective. Make sure you understand how HA and DRS are involved in the design and put the settings in place that we talked about today. Make sure you test the failure scenarios during POC to make sure you validate that your design is incorrectly. And ultimately try and automate as much of the provisioning process as you can to remove errors in virtual machines being on the wrong storage at the wrong time. There's a paper that we've got a link to at the bottom there. You'll get the slides. Our Twitter information was on the first slide. Please send any questions to us if you have them. Any other questions we can take outside in a second if you want to chat outside. But other than that, it's gone 6 o'clock, so I really appreciate the fact that you've stayed this long. Thanks for coming. Hope it was useful, and enjoy the rest of the event.